All right, so today's video is going to be about the next question that we have in our list is a CLI calculator. It reads the expression from standard input in a loop, build comforts with parsing, pattern matching on result and an option, and the loop that doesn't fight the borrow checker. So this exercise goal is to get familiar with the user input that we are going to take from the user by making this calculator, right? And we'll also do some pattern matching. We'll also deal with results, some of the errors, and how to parse strings and all. So with this exercise, we will be able to kind of do all these things, right? We'll be working on calc, right? We'll do cargo new, and along with that, we'll open it once it's done, right? Oh my god. Oh, I have to open basically the calc one, right? Like this. Okay. Few things before implementing this thing. Let's learn what this thing is. Where is it? Okay, this one is. Okay, CLI calculator. It reads the expression from standard input and build comfort with parsing, pattern matching on result and option, and a loop that doesn't fight a borrow checker. So this could be the example that we have to implement. A user will enter 3 plus 4. The answer will be 7. And again, it will be like the input is basically open, right? So the user gets an answer. Again, the terminal is again asking for the input unless it's specifically typed like quit Q or press Control C to force exit the program. So we have to do this, right? Let's kind of discuss what we have to do. Okay, basically we have to create a simple program like that, and the user will just input like the questions that he want to like ask, like what is 3 plus 4, right? Or basically 3 into 4 or whatever calculation he needs. Okay, user will ask, and this input will be feeded to our program that we will create over here, right? It will be our CLI app. Okay, the main thing about this is this thing over here, this input asking thing, it has to be in the loop. Okay, why in the loop? Because we don't want that, okay, the user asks, okay, what is 3 plus 4, and the program quits. That would be a bad terrible thing to do. Maybe starting you can like just create it like that. Okay, start with the basic simple minimal thing first and then do the improvements. Okay, so yeah, we can do that as well. Okay, CLI panel, and few things that we have to kind of take care about while implementing this thing, this CLI app, is we have to understand results, right? We have to understand matching, right? Pattern matching. We have to understand how do we handle errors, right? And what else can we do here? Yeah, and we will understand how to make the basic template for a module, right? We are not going to like push everything over a single file. We are going to create a module out of it, and then we will call these things in our main file. All right, so it's a basic simple structure. User inputs something, it will be like asking on loop, and also we have to like make sure of one thing over here, that is proper shutdown, right? We have to also deal with this thing. We have to make sure that the error properly kind of propagates from the module to the main file, and it can be shown to the user as well. Okay, so this thing we have to kind of like implement. So I hope you get the idea. It's pretty simple thing. The only thing, okay, so calculator is basically simple. The only thing it needs is the things that we'll learn from it, like results, pattern matching, how to handle error, how to implement errors, right? And few other important things like that we'll face while implementing this thing. So I'll try to do all the things at once on this simple app. Okay. And yes, of course, we'll learn how to, properly create a module that propagates error from a module to a main file from where these function will be called. Okay, let me just refill my cup. If you have any question, by the way, you can just ask. Okay, so let's start this thing. We'll simply just say it's a calculator, right? So it's a calculator. Let's start from the very scratch. Okay, how to tackle these kind of things. So let me just create a folder over here, calc. Inside this I'll create mod.rs, and over here I will create just calc.rs. And on the mode, what I'll do, I'll say calc, right? And this entire module has to be there on the main, so I'll simply just do mode. Okay, now let's go inside calc. There is nothing on main we have to do. First of all, we have to like create and design our calculator, then we will do the calling part. Okay, so maybe you know what, let me think. I think in this case we have to let's ask the user for the input, because if we are going to ask the user for the input, let's design this thing first so that we can test whether it's working or not, right? We can simply ask the user and print it. Okay, so how to take input? So basically input for like handling the input, we will use stdin. Okay, the method provided by the standard library in Rust. So let me just write it. Okay, this is the one. I will just simply import it, stdin. I hope you are going to like, let me just check the OBS if this font size is proper, because you guys are not going to tell me. Yeah, it's not. 1 2 3 4 5. Is it good? Or 6 7? Yeah, good. Okay, so standard in that we have used, right? What it takes, it takes nothing. It just omit out the standard input, right? So so the few things that have to keep it in mind, that whatever we takes like the input from the user, it has to be stored in a variable, right? So let's create this thing. I'll say let input equals, I want this to be a string, right? So I'll create an empty string over here. Okay, and let's take the input from the user. Okay, I'll say stdin dot read line, right? See the signature of read line. it takes the mutable reference of the string and it returns a result, right? So let's do this. Okay, it returns a result of a u size. Okay, it returns a result of a u size and an error. All right, see, the result came into the picture. Now we will see how to handle this thing. Now it takes the self and of course a buffer, right? A mutable string. So I'll say and mute input, but we will definitely will get an error over here because this string has to be mutable because user keeps on entering and we need to mutate this input, right? So this has to be mutable. Now the error, let's see the error. Okay, now let's handle the result type. I hope this is not overwhelming. This is very simple, very basic, right? The main purpose over here is to handle the result type so that we don't like kind of accept like, you know, unexpectedly crash this program. So I'll say in you know what, I'll say response equals, I'll just do a match over here, right? I can use question mark, but that will not be necessary. Why? It is not recommended over here because question mark basically it is used to propagate the errors. Okay, so I'll show you in a bit, because if there is a separate module somewhere and I need to propagate the error to the calling function, so I can do a question mark basically. Okay, so what the question mark does is, this is what I'm doing manually over here because I want to handle the error here, not just to propagate, right? Because this is the main file. So result returns an OK of response, that I can return the response, right? And an error, of course, E error, right? And what I can do over here is I can print the error, right? Error on taking the input, right? I want to show the error as well. So yeah, now let's face some errors over here. Okay, it says I need a semicolon, otherwise it would be considered as a return, so I just do this, right? And said match arms have incompatible types, right? It expected u size, but what I'm returning from here is unit, right? So what I can do over here is I can say process dot exit 1. Oh no, right? And why did I did this? Because see, the main function over here, the response over here, the first thing that I returned is a response, right? And the response is a u size, because this read line function, it returns a result of a u size, right? So I returned a u size, but on the error over here I returned nothing. And this process dot exist has a return type of, okay, it has a return type of this. So this is a valid return type in Rust, exclamation mark. So whenever I do a process dot exist, it means it returns nothing. Definitely the program is going to like kind of end over here, stop over here, right? So it basically returns a exclamation mark. Okay, so there are some functions that return this type. All right, it's not recommended, like not very recommended. I mean, you cannot return it from the other functions, like you cannot return from here, but when you, let's say you don't want to return anything, a kind of the program exits, then you can use this type. So this way it handles this error over here which says the match has incompatible arms, right? And also we want the program to be end if there is a error in taking the input. Mostly the error would be from the terminal side, because there is nothing a user can basically go wrong, right? So that's why we want the program to exit, because a terminal is facing some issues. Okay, now this response I have. Okay, let's see what the response is. Okay, it's a U size. All right, what are you creating? Hello, 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 Extreme. How are you? So let's do a cargo run. Calculator. You get the answer, buddy? Calculator. But the project is simple, but few things that we'll learn from here: how to properly handle error, how to handle result types, how to do a proper, pattern matching using match. Yeah, I'm good. I'm good. Okay, so let's say Vipin Yoshi. The response is 12. What the heck is this? I entered Vipin Joshi and I got 12. What is this? 1, 2, 3, 4, 5, 5, 5, 10, and spaces for 12, right? So it means this read line basically it is sending me the U size response. Okay, now how to do that? How to fix this thing? Okay, that means input taking is like kind of working, right? This was the very first thing that we have to think of while creating this project, because it's an CLI app. It is expected to take input, right? So this is how a user take the input, gives the input, right? Now one thing you have to note over here is, as soon as I enter Vipin Joshi and do an enter, it sends me what it received as a U size, and the program exits. That I don't want, right? I want it to like keep asking user what's next, right? So for that, what we can do, we can have loop over here, and this has to be inside the loop, right? This has to be inside the loop. Now okay, let's run again and see if that works. Calculator, I say Vipin, it doesn't print anything. Vipin, 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 okay, doesn't print anything because we didn't print it. So in order to print that, we have to do this println, right? Response, right? So let's go over here again and clear this thing and hit it again. I do Vipin, it gives me response 6. Now the good thing over here is it is now also like asking me to again enter something, right? Vipin 7, 32. So CLI is still waiting for me to enter the input. So this will be our core of this app, right? This is what we want. We want the user to keep entering until the user, let's say, press Q. The response is 2, of course. Until it presses Q, that will handle, and the program quits, or it types just quit, or just press Control C. That is the forceful way to do so. Okay, so we can do that. We'll like kind of furnish this thing later, but let's do a few things first. Now you see, we have to think of few things over here as well. Let's say user enter 3 plus 4, right? Let me just go on the this thing over here, 3 plus 4. It also says 10, right? And it also says 10 divided by 0. So you see, basically three things are involved over here, right? If I just say it ABC like that, right? Let's say I just want to denote this A and this as B and this as C, right? So 3 and 10 will be A. The operator in between them, like plus, divide, multiply, and everything, right? That will be B. And the third thing over here, the number like 4 and 0, let's say it would be C. So basically there are three things involved, right? So we have to make sure that this thing will use this kind of concept in order to pattern match this as well, because when we get the input we need to kind of somehow detect whether the user want like these things to be added, these things to be divided or not, right? So we will also pattern match this thing. So maybe we can do a pattern matching on this thing, and we can then just pass B onto a special function that matches that whether it's a plus, minus, multiply or divide, and then we can just perform all these operations, right? So how to do that? First of all, we have to convert these things into characters like chars, and then we somehow collect those things, Why I'm doing this? Because let's say I typed V, right? I typed I, and I typed P, right? And so on. Okay, it would be like the characters V, I, P, I, N, and when I collect these things, it will become something like this within, right? For in this case, it is VIP, right? And yeah, so this is what I want to do. I want to just collect the chars and to make it a string. But for that, this thing what I'm getting over here is U size, and this has to be this. You know what I need to do? I think I missed few things over here. I don't need a response. Why? Because I'm mutating this string input, right? It's already in the input. So if I just print input over here, let's see what I get. Let me close this. Open. Voila. Nice. This could be very useful. Yep. It could be, yes. Okay, see, whatever I entered, let's say I love this. I love this. I love this. So I get the response back when I love this. Ooh. When I love this. Ooh. Is it entering like a new line on it? Okay, see, this is mutating, right? So this is mutating. So earlier it was Vipin, then it was Vipin I love this, then it was Vipin I love this. Oh, then it was oh, right? So this means on every item that we push, every item that we push, like this. Yes, it is now. Okay. Okay, we don't want to append it, so this saves our purpose, right? We have to like put it inside the loop so that it doesn't get appended to it, right? Because it's a string, so it will get just appended to it. Okay, now this is good. We can get the response. Input is keep on updating, so you understand like how to manage this result over here, right? Read line. Definitely we can just almost like but it's okay if you want to like do it like that. Okay, what's the next thing? Comfort parsing. Okay, Now let's see how do we do this thing ABC. Like how can we like figure out what operation user want to perform, right? So for that, let's see if I split input, because it's in string, right? If I want to split it based on the white spaces, so do I have the option of split white space? Okay, split white space, and what does it return? It returns this thing. Okay. Hopefully it will return a vector. Let's see. It doesn't implement display. Okay. Cargo run. If I just say okay, weapon, well, I get the chars over here, and along with this I get a new line. So basically we have to trim this. So basically these are the chars, right? These are the characters that I get. So you see what I was saying, like I did this part, right, Vipin Joshi, but what I get in return is chars, characters, right? So if I just trim it on the white spaces, I get a vector. So let's handle this thing. First of all, we'll have to also trim this thing, otherwise we'll have oh, right. So if I just do trim, okay, now let's see it again. Now I am like, I kind of rid off from the new line that it was showing me earlier, right? Okay, that is fine. Okay, now what we have to do, maybe let's just say this, let you know what, let response, maybe it should be a vector of view size input dot trim dot split white space. Mismatch expected this, found what, I need to check it, found what. Let's do a cargo build. I am doing this because I have like kind of extended my, like increase the font size, so I'm not able to see the proper message. Found this and I got this. Wow, explore white space. Out of this. I think I'll get the same thing, right? Yeah. Cares. Do we have any function here? Map. Yes, we have collect. We have collect. Now this will be converted to vector. But vector of what? Let's see. Maybe I should not like kind of do this for now. Cannot satisfy from iterator. Type annotation needed. Of course, of course. cannot be built from what? Stem iterator str expected this, found this. Okay, so it is this, right? It's okay, even if it is a slice, will not do much harm, I guess. Okay, amazing. I get this thing now. The next step over here is we have this statement now. So I can get the vector over here, right? I can get the vector over here. And this is the first part. Now let's say I want to do something like this, 12 into 13, right? I don't want this. It's a complete string slice. How do I figure out like which is the operator in between? As I told, we have to like kind of, we can go by this philosophy, because let's say a user say 12 plus 12, or 13 into 13, or 10 divided by 0, right? So there is a common pattern in between them. There is an operator in between, right? There is an operator in between. So we need to figure out how to like get that operator, so that we can do a pattern matching on this thing, like whether what is the operator like, right? So I have this thing, right? So before that, let me just implement this thing so that I can have an option to the user so that it can quit the application. So if I say if input dot trim, can I do a trim over here so that I can avoid all these things? No. No. Okay, because it's a new size, how can it would be like that, right? Yeah, so if input dot trim equals quit, right, or exit, can I do this? Then I have to break the loop, and once I break the loop, it's over. See, the break also kind of has a return type of this. So break, continue, exit, they all have the return type of this thing. So if you basically, it means the program is going to be, and now it doesn't return anything, so it satisfies this thing as well, right? And it satisfies these match arms that do not match the size, right? I think, yeah, we cannot do that. Maybe we can handle that where we have to handle the operator, right? Okay, so we have the vector now. Now how do I get the those things? Do we have anything over here? A split of s pointer? No, we don't need them. We need a kind of r split. First chunk push ptr split. A split at. Okay. Don't we have something like slice or something? Ah, we get it. Okay, we have a splice. No, not that, not that. I think this was it, as slice. See, it is returning, it is giving me the vector of these character, right? And if I do this, I can get this thing. Okay, let's see what it gives me. Let me just control C. If I do a weapon, it is giving me this as slice. Response dot as slice. Can I do this? And because I'll get this slice, right? So I get this thing. So if it's empty, I doesn't do anything. Oh, that's what I like kind of suppose to maybe continue. And if I, so here I can deal with this, like, you know, a quit, a queue or something, then I can perform these things over here. Quit, or just let's say exit, and then I can simply break the loop. Now here comes the thing. Let's see, what do we get here? I'm just shooting the arrows over here, guys. So let's see how it goes. A response. Input. Okay. So the second would be the operator, right? So we can denote it by this, and the third would be the third thing, right? So I can say A, B, C. You know what? AB instead of AB, I can use OP. C, never used. Okay, yeah, that makes sense. And okay, non-exhaustive pattern. Let's do something over here, and I'm going to do a thing for I'm going to do just nothing over here, right? So this implementation that we are doing is not very good. It is a like very specific to this example, and we are expecting spaces in between the operands and the operators, right? We are expecting the white space in between them. But again, if you want to modify this thing, we can have a, you know, have it like taking multiple things in between operands and operators. And also this thing has to be also like handled if there is no white space. But again, let's see. I mean, cargo run. I do 12 space plus space 12. Wow. Now this works. Okay, so I have the operator now. But again, I am not very satisfied with this thing. It is just like kind of basic, very basic, without handling any edge cases and all. It is an absolute shit that I'm working on, because it doesn't handle any case, right? What if user says it's not a thing about white spaces. These things are also not handled here. Plus 12 plus 12. What if user does this, right? I cannot have multiple match like arms, right, to see another matching over here. See, nothing. The loop is working over here. I get like this thing, right? So this has to be removed. And do we really need it? Hmm. So at least let it make it work, right? So okay, now I have this pattern, right? This is the very hard-coded pattern that okay, I'm like expecting only two operands by the user. Okay, the user is very dumb. It will only like enter 12 plus 12, 13 plus 13, only two things. So first of all, few things that we can handle over here is I don't want the user to add two number to a string, right? I don't want to do that. So I have to parse those operands like A and C. Okay. So over here, what I can do, what file is this? This is the main one, right? So, okay, I don't want the user to parse all these things. So what I can do, I can create the function to parse those operands and to map and provide the answer based on that operator. We can do it on the separate thing, right? Separate module that we have written. So we are going to do that. So first of all, we are going to do something like this: parse operands, right? And we are going to pass A and C. Okay, A and C. And as I already told, we are going to kind of implement or learn about result and pattern matching and errors and all. So we are going to do that. So this could be this is what we are going to implement. Of course, here we need to do is handle the results that we will send back, right? The error that we will throw back over here. So if I go over here on the calc, I can create this thing. Let's say public function parse operands, right? And if it's true, I am going to return true. If it's false, blah blah blah, like that. So basically, I'll have to do this thing. I want to show you how to do that. I'll pass result boolean, and over here, what I'm going to do, I'm going to do this error. Okay, and this parse operand, of course, is going to take A, right? That is a slice, and C, that is a slice, right? And I want to parse it, right? So what I'll do, I'll say A dot parse, right? And I want to parse it to like that. So now what it returns? It returns either result of I32 or an error. right? So if it's so yeah, this is how to propagate the error from a function. Okay, so you don't have to do manual thing to just do a match over here. But if you really want to take the control of the function, that you should have everything, you know, under control, so you can do all those tedious things of writing a match over here and then, you know, extracting or pattern matching that thing with an okay or an error, right? And all these things, it could be done by a single question mark. So what question mark does is it propagates the error on the to the top, okay, from where this function is being called, and we have to obviously handle it there as well, because you're right, we cannot depend or kind of leave it like an open-ended thing over there. So we have to handle that thing on the main file from the caller function, you can say. Okay, so but again, there are two things that we have to kind of uh, parse those things basically. And why I'm doing a parse over here, because I don't want the user to add, let's say, two to anything, let's say extreme. I don't want to add two to the string extreme. So if it's an error, because extreme is not going to make it, because, you know, extreme is a string, it's not a number, right? So I cannot add a number to extreme. So this way I use this method parse to test those things, right? Now again, because those two can always throw an error, so what I can do, I'll have to use a match over here, because I have to just deal with these two, right? So you know, in case of, if everything goes well, what I'll do, I'll just return okay, right? I just return true if all goes well, right? But again, here I have to match all these things. Let me just put the question mark. Okay, and over here error, right? On okay, I don't want to do anything, it's okay then, right? And if it's an error, I can just simply return error like that, and I can return this thing, right? And we have to, okay, found parse int error, right? Now here is this beautiful thing about errors over here. See, the error on the top is an IO error, right? But when I'm parsing this thing, it is expected to throw an error related to parsing, right? So you see, it says found parse int error. Now here is this thing, you have to understand. See, I am just parsing these two things to an integer, right? Or maybe to a number, right? Anything, right? So what I can do over here is, I know that these two things have to be a number. So either I can, instead of an error, I can simply say parse int error on the top. But if not, and I don't know the type of like error, right? I don't know the type of an error. So what I can do, I can use box din error, right? And that box din error will kind of help me, or help this function to take the error of any kind, okay? Because the error is not known, basically. The box din means there is an error, but error is not known at the runtime. It will be decided, its type will be decided whenever I get an error. So in that case, we use box din, right? Box, why do we use box? Because this box, it places that error thing on the heap. And clearly, if we are using box din, we don't know the error while writing this thing, okay? And the error will be caught in the runtime, and at that time the type could be anything. So in order to handle that, we can always use a box din error, right? we can say like this, right? We can say it like this. Now see, that entire thing has gone now. It is not complaining us about the int 32 error or something. Okay. Now there is a different thing over here. Okay. It says found parse int error, but expected is a box, right? So there are things, idiomatic things that Rust provide. So if I do an into over here, you see the function signature, whatever it takes, it convert into the generic thing, right? So if I do an into over here, I am supposed that the error will be gone. Yes, the error will be gone. Expected I32 found this thing, right? I don't want to do anything right here, so I'll just simply do this. Okay, now this error expected trait, what? Consider importing this trait instead of, yeah, we can do that. Multiple times. Okay, so you see what we did here. Whenever we create a function, right, and if you want to define a result type, a return type as a result, because I want to be in control of that function, so I have decided to return a result from here, a result of type boolean, and in case I get any error, I just returned an error over here. But again, there are things, because currently I can see that there are two things, right? And I know what the kind of errors will be returned while like writing this code. But you will encounter these things in when you write some APIs or something like that, or any function where you don't know the error type, because there can be multiple things, right? And it's not fixed that a function will always return a simple or a single type of return, because there are multiple variables involved in that function, right? Currently it's a very simple function, but if this function could be more complicated, then there are other things as well, and they all can emit their own errors, right? And because every line of that inside that function can do different work, maybe it can call some other promise that returns something else, maybe it calls another function that is doing something and can return a different error, right? So in that case, this function doesn't know which specific error has to be written. So in that case, we do this boxed in error, right? And whenever we do an into, it just convert into the return type of whatever is asked, right? So this is how you do. Now again, the same thing goes for the B as well. So let me just do this. Right. Cannot find B because it's a C. Okay, so both of these things, whenever I have any error, right, so I'll just simply return, and if they are okay to parse from this thing, it will be okay, right? So let's go on the main thing. From here I can just import this thing, and I'll pass this thing over here. Okay, now it says it returns a result. If I show you the function signature, it says it return the result of all these things. So we have to handle this, right? So how do we do that? I can always pattern match this thing, because a result will have either an okay value, right, that we really don't care about, or an error, right, that we care about over here. I can say println enter proper input, we can say, right? And just to be more specific, I can show the error to the user. Okay, so that result type has been handled there. You see how do we pass and propagate the errors? We create a function, we pass the result error from here, right? We do this, we return the error wrapped in a box bin, and on the calling function, that from where this function is called, we handle this thing. So this is how you handle pattern matching, and you create errors from a specific function and just use or wrap it around a result type so that the calling function has to handle those. Okay, so this way the function looks more controlled, the program looks more controlled, right? And after even the error has occurred, you can just either continue or break, it's up to you. Right, so we will continue. Okay, otherwise we can break as well. Now the operands has been like kind of parsed. Now I want to perform the actual operation over here, right? Because I encountered this pattern here, I just do some performance checks over here, right? Instead of writing handle the results, I can say check for operands, right? And after this thing, what I can do, I can just match for the operator to perform calculations, right? I can do this. So again, the same way we can always have this thing. Okay, I'll also return this thing from here. So I'll say calculate. I can do this thing, right? Calculate, and I'm going to pass A, OP, and C, right? I'll do something over here that we'll figure out. Okay, now let's go inside the parse operands, right? I'll create another function. Let we have it, right? str, we have op, and we have c, right? And it will return again the same thing, result. And now this time I want to return a string. Okay, and again a box, right? Here I'll do the calculations. Okay guys, so now let's satisfy the compiler over here. I can just say this okay, so let's implement this thing again. On the calculate function, we will perform pattern matching on the operator, right? On the operator we will perform the pattern matching. Hello. Okay, mic is working, and yeah. So I hope you understand this, right? Now let's do this. Calculate. So before calculating, we have to figure out what operator is that we have to perform, right? Is it plus, is it minus? So we already have slices, right? And we have this operator over here as well. So we'll always do pattern matching over here. And if I do op, I can say, just simply look over here. Yeah, I can say if it's a plus, then I can perform something, right? If it's a minus, I can perform something, right? And if it's a divide, I can perform something. And if it's a multiply, I can perform something. Right, again, let's handle the exhaustive case. Other than that, what I can do, I can return a kind of set of instructions from here, because the user is definitely not providing this thing, and we are not going to solve higher order mathematics over here, like square root, integration, differentiation and all. Okay, so we'll do simple basic maths over here: plus, minus, divide and multiply. The idea of this exercise is that we understand few things. First, how to work around results, how to do pattern matching on string slices, how to take users input, and how to propagate errors from a module to a main file to a calling file, and what is like box, din, error and all these stuff. Okay, so for the higher order mathematics over here, definitely we can say we can pass in the instruction, right? So we can say usage A, operator, and B, right? We can say this, or maybe we can say contact extreme for higher order mathematics. He is working on this AI and shit. So of course we have to return okay from here. Again, it's not println that we have to return, right? We have to return a string from here, so we can always format this, right? Let's see. Incompatible type, of course, incompatible types, because we haven't worked on it. Okay, so the return type for anything over here is to pass the string, but instead of passing the string, maybe it would be easier if I pass the floating points. You know what, because the numbers could be f64, so maybe it's better not to specify only I need that this thing I32. Cannot infer types. If it cannot infer types, then it would be good to not use into. Cannot satisfy boxed in error. Why? For an instance, if I do a dot parse and I do this, expected this found okay, right? I do this, transfer not verify, implement trait from str. Can I do map? Can I just say like, oh, instead of map, have to do map error? Can I do like this? And if I say like that, from str, right? So maybe I can just let's do this. not a number. Closest take to take one argument. Okay, let's do this then. Cannot satisfy. Okay, anyways, let's not get into this thing. We'll handle it later, right? For now, let's do this. Okay, okay, so what I can do over here, if it's a plus, I can just return a plus b. Oh, a plus c. Cannot add this. Congratulations required own string on the left and the left. I thought we can just like we can always parse it, right? Oh, so this is something has to be changed. This has to be changed, guys. This has to be changed. Oh my god. So eventually this function, it tests whether this thing is or not, but eventually we have to parse it. We have to parse it. So maybe I can create a simple single function, right, and call it 2 times rather than calling all those things at once. Okay, so let's not do this. I have to pass only this thing, so I do this, and instead of true, maybe I can just pass in the f64, right, and I will just pass these things into float. That's why I was thinking, so instead of this, what I can do, I can give number back, and over here I can always say a and let number goes this. Cool. Now parse operands. I don't need to have like these two things at once because I have to parse those as well, right? So here I can have 64. Why I'm writing this? Because I don't want to call it like multiple times to parse it again and again, right? Oh, this has to be string only. This has to be f64. F64, right? And I can always do an okay, a minus b, right? For the divide, we have to handle the divide by zero thing over here because how can we do that? I want everything to be generic, not generic, I mean controlled, right? So it says if I do this thing, I have to show this division by zero, right? So what I can do over here is I can say if c equals 0, I can simply return an error, right? Error, and right, can I do it like this? New, no. Can I do this division by 0? Maybe I can just say return, right? and this way the error would be 0. Otherwise it will just return A by C. Oh my god. Found I32. Le bhai 0.0. Okay. Expected box in error found this thing. Okay. Expected unit type found result this. And what is that? Anyways, let's do this thing. Okay. A multiply C. Right. Found unit type. Unit type, baby. Unit type. Okay, let me remove this thing. Now this is, maybe I can now remove this as well. Okay, so the error was from that side, right? Okay guys, wait a minute, I am getting a call. Let me just pause this thing. Okay. So yeah, so we have some error over here. What it says? It says XFF found string. Okay, it says expected F64, but I get a string. So in case I have this thing, maybe I can just, print this and I can say okay. Right? Unnecessary parentheses around. Yes, sir. All right, so the calculate is over here done. Let me remove this. So the parse operands, we have to create one function eventually because we have to like get the numbers as well on the F64, right? On the main, we can do is instead of like doing kind of single time, we can do this, and we have to do this again and again, right? At least for the two things that we have to do. So that's why I said this implementation is very shitty, because everything doesn't make sense here. Like it's hard coded, right? I am expecting only like two things, A plus B basically, right? And there will be an error. Why? Missing arm. Okay, an error. Okay. Okay, sir. Okay, I have to print the result over here. And of course I want the new line, and for the error I can always have this thing, because I'm going to have an error, right? So I can always println this thing. And continue. I'll continue whatever it becomes. Okay, found this, expected this thing, right? Now here I have this thing, so I can say A, return the A from here, and just I can see and this thing over here, and I can say let first C equals this, and let first A equals this. Instead of A, I can say parse A and parsed C. So you see, this basic simple calculator, I think it is done. So the goal here is to not create a basic calculator because it doesn't have any logic. It doesn't handle any edge cases, right? It doesn't handle any edge cases. You see the implementation of total logic over here is A plus C. That's what Rust is doing by default, automatically doing some maths, right? The only thing to learn from this exercise is how do you create a module separately, use that module on a main calling file. How do you work around with result types that are being returned from the function? How do you handle errors? How an error is different from this statement over here, box din error. What does the box and din do? How do you propagate error from a function to a calling function? So all these things that we have learned over here. What is dot into, right? What does dot into does? How do we parse the thing? What is the syntax over here, right? So yeah, that's what we learned from this thing. Again, this project itself, the simple CLI app itself is very, it doesn't handle all the edge cases like I already said, because the question says you have a fixed set of output. The user is basically dumb that it will only pass things like this: 13 space an operator to work upon, space and the second operand, right? So the user is supposed to be dumb and pass only this thing, but a smart user like you can always ask, what if I do this 12 plus 12 plus 12, or 12 plus 12 plus 12 into 13 divided by 99, right? Because it's a calculator. So this kind of case, this is the edge case over here, as you can see, it is not handled over here, right? Because it needs a separate implementation. Okay, and we need to figure out over here, like, how do we like remove these operators and how do we perform all these things. How can we implement the BODMAS rule over here and all. But a simple application over here according to the this question is done, because the purpose not here to implement a complete this thing, right? The main purpose of this exercise is how do you read expressions in a loop from a standard input by a user. How do you make yourself comfort to do parsing, to do pattern matching on a result, an option, and how do you figure out that loop doesn't fight with the borrow checker and ownership borrowing rule and all. So the purpose is solved. Now it's time to check it, put it to some check. So I'll do cargo run. So few things that we handled is, what if I do a queue? I want to quit this, so let's say I type quit, bye bye. Okay, it's done. Cargo run. I'll say 12 plus 12. It should show 24. The output is 24, and the good thing is it is again asking me for the input, right? It doesn't closes, it will ask. Now let's say I want to add whip in plus 12. What should it like do? Because we already have the parsing in place, right? Weapon cannot be passed to an integer. Okay. Enter proper input. Invalid float literal. You see how controlled our program is, how controlled these errors are. It is not doing anything unexpected, right? It is not just crashing. This is called the graceful handling of those errors. It is working as expected, as if I am in the control of this program, right? I control this program. Why? Because I'm handling the errors over here, and that's what the goal of this exercise is, right? The error over here, as you can see, is enter proper input. And where is this written? Enter proper input. It's written here. Where? Where is this? Yeah, enter proper input. So the error always throws in this case is from the parse operand, right? Because I'm parsing the operands, maybe from here only, right? Because weapon cannot be parsed into a float, so it goes inside this error, and I'm continuing after it. If I implement a break over here, the program stops, but I don't want to do that. I want the user to again try a different things. So if I go inside parse operands, you see what I did? I'm returning a boxed in error, and in error in that case I'm just showing it is invalid float return. Okay, now it is for the operand A. Now let's check for C. If I do J key, again invalid float literal, because 12 cannot be added to a string J key, right? And if I enter as empty thing over here, this is also has been handled, right? This is also handled. If I pass an empty string, it will just continue. Now let's perform some things. Let's say I want to do 10 divide by 0. So guys, if I divide any number with 0, what could be the output? It should be like an error, right? You cannot divide any number with 0. That is the error, and that we have handled, right? If the operand C, that is going to be like the component in the denominator, is 0, it says division by 0. Basically it has to be an error. So let's it's an error from the calculate. So but it doesn't look like, right? On the calculate, what we did, we just printed an error, right? So basically what we can do over here is I can say error, right, like this. Okay, now let's go again and test it. Cargo run. I'll say 12 divided by 0. Now I get the error division by 0, the controlled way to do so, right? And what else? 12.5 times 2, right? 12.5 12.5 times 2, 12.5 times 2, the output is 25. So this is expected. 25 division by 0, 3 plus 4 7. So this is completed. The fourth exercise on the PDF is completed. Again, the goal of this exercise is not to create a calculator. The goal of the exercise is to get yourself familiar with how to read the expression from standard input in a loop, right? How to make yourself comfortable with parsing all those things that you have taken from the user, how to do pattern matching using a result, right? And how to deal with the loops. How are the videos? Hello. How are you, man? Yes, it's been a while. Yeah, I also like kind of coming online from past 2-3 days, from the past like 3-4 months maybe. I took a break, of course, from the YouTube. So I was working with something. How are you, man? Good to see you. Yeah, so okay, so this is done. The only thing that we have to do over here is, that is not in the exercise, but that should be done is, instead of like assuming that user will only do 2 operands for any like input, we have to handle these cases as well. So maybe you guys can try it out, and on the next stream we can just implement this, right? So yeah, I hope this is not, I hope this, you are not getting like overwhelmed by this. It's a simple thing to do. So with any other language, oh amazing, good to hear, Darky. So with any other language, this could be done like in few lines, right? It could be done in few lines. Maybe you can make it even more modular to check for these things and implement. With Rust, it could also be done, but here we have like implemented some checks like how to propagate the errors and how to use result, how to use boxed in errors, how to gracefully handle errors and not let the program crash, to be actually in control, right? So the purpose is served here, and yeah, this is very simple thing to do. But again, the goal was not to build a calculator, it was to get yourself familiar with all these things. All right, so the next exercise on the list would be, again, definitely it would be to handle these kind of cases like multiple calculations, the priority over here, how to do it, right? So we'll do that next, right? It's again a logical thing now, there is nothing to understand with this one. Of course the logic has to be built, but the core soul of this exercise is done. Okay, so if I want to look on the fifth one, the next would be the multi-threaded word counter. Okay, it is commonly asked in the interviews as well, like how many times the occurrence of a word in a sentence is, like the you can see over here 1 2 3, so it occurred 3 times. So the solution would be to maintain a hash map and use these word as a key. Whenever it repeats, increment the counter, otherwise add it as a new key. So this would be done. But the more like kind of the thing that we have to understand from this exercise is to use it in a multi-threaded environment, and the difference between like all these things, right? We have to always maintain hash map again, but we have to understand what is a mutex and arc over here. So the exercise of this like the fifth exercise of this PDF, the goal is to understand multi-threaded environments, and yeah, without doing like touching Tokyo, do this before touching Tokyo, so async cooperative models feel like a relief rather than another arbitrary API. So this could be done next. Okay, all right, then I'll see you in the next one, guys. Bye bye.